Hello chemists, we are going to be going over some tips and tricks for properly identifying the presence or absence of various bonds on infrared spectrographic printouts like this one. When you are approached one of these that you haven't seen before, your first step should be to look for the four kind of most useful types of bonds to identify the presence or absence of. Those are your N to H, your C to H, your O to H, and your C double bond O. Whether those are present or not is going to tell you a whole lot about what sort of molecule you are dealing with. Usually I start with N to H. The reason I start with N to H is because based on your mass spec graph, you should know at a glance whether you're dealing with a nitrogen or not. If the molecular ion mass is odd, you're dealing with a nitrogen because nitrogen is going to bond to 3 hydrogens, meaning that the total mass of the whole thing is going to be odd. And if you're dealing with an even number, you know that you're not dealing with a nitrogen. So odd number could mean nitrogen. Even number means definitely no nitrogen. So if you've got an even number, you know there's not going to be a nitrogen peak. And you can just go ahead and tell me absence of a peak at 3300 to 3500, or 1000 to 1250, or 2850 to 3000, or 1550 to 1640, or 1590 to 1650, that being all of the locations from the table. If there's no nitrogen present from the mass spec graph, you will already know that there shouldn't be one on the infrared graph. So first we look for the presence or absence of that nitrogen. This graph, it is not present. Next, I would look for O to H and C to H. I look for both of those together because they generally appear in the same area, kind of right around this zone here. That's where I would be looking for my C to H and my O to H. C to H tends to be quite quite narrow. O to H tends to be quite broad. This looks like a broad peak to me, which suggests the presence of O to H bonds. C to H bonds are still going to be present. It's just if the peak is broad, it's going to include the C to H peak and be an O to H peak. So presence of C to H and O to H bonds. This peak is not particularly strong. I would describe this as a medium strength, broad peak at between 3200 and 2500, roughly. Although once you identify the molecule you're dealing with, you can be more specific with your descriptions. You can say specifically, this is a O to H peak, an O to H stretch peak, excuse me, present in the 2500 to 3300 region. And it overlaps a C to H peak present also in the 2850 to 3000 region. So this peak right around here, if it's narrow, is going to mean C to H is present. If it's broad, it's going to mean C to H and O to H are present. Our last bond we want to look for is a C double bond O. That usually presents as a peak right around kind of in the 1700 region. I can see that here. That can be a C double bond O for a aldehyde, for a ketone, for carboxylic acid, for an acid chloride, and for an ester. And I can already identify which one it is. I know that it is not an aldehyde or a ketone because I have this O to H peak here. Aldehydes and ketones not having O to H peaks. I know that it's not an acid chloride, probably from my mass spec graph. My mass spec graph is going to tell me whether I'm dealing with an acid chloride or not. If the mass is very, very high, I'm more likely to contain an acid chloride. If it's not very high, I'm not likely to contain an acid chloride. And I know it's not an ester because esters are not on the exam, so it won't be an ester. That leaves the presence of a C double bond O in the carboxylic acid functional group. And I now have enough information to say that what I'm dealing with here is a carboxylic acid. I have my C to H and my O to H there. I have my C double bond O, and I have no other peaks. So I can say no peak at wherever my nitrogen peaks would be expected to be. That means that it's not got a nitrogen in it. I can say broad peak at the at 2500 to 3300 indicates the presence of O to H. I can say that broad peak also indicates the presence of C to H, and I can say that this strong, sharp, narrow peak at 1705 to 1720 indicates the C double bond O present in the carboxylic acid. I can also identify possibly some other peaks. I would expect to see a C to O bond in the 12, 10, 13, 20 region. That does fall in the fingerprint region, so you don't need to refer to it. Remembering that everything under 1500, everything this side of 1500 is mostly ignored. So that's enough to identify my molecule as some kind of carboxylic acid. I don't know how big it is. I don't know how many side chains it has. All I know at this point is that it has a carboxylic acid on it somewhere. Key points to wrap up are that the presence and absence of peaks are important. You should look for N to H, O to H, C to H, and C double bond O peaks first. You should describe your peaks with location, that is numbers, and those numbers should come from the table. A description of the peak, which should say strong or weak, broad or narrow, sharp or not, and that your goal here is to identify which functional groups it is definitely not. I find it's more useful to approach it from the position of trying to eliminate things rather than trying to work out what it definitely is. So as soon as we see an O to H, we can say, okay, I know it's not an alcohol. Sorry, as soon as we see an O to H, we can say, I know it's not an aldehyde or a ketone. I know it's not an alkane. I know it's not an alkene. So we want to eliminate things, and hopefully we should have only one or two things left, and the other graphs can help us fix that one. That's it.